Jag heter alltså Hans-Olov Ericsson. And company called Wind River. And the reason we are here is it's interesting because Wind River as a traditional company comes from a different angle than user IT systems that some of you might be used to working with. We come from an embedded side, we come from real-time operating system, we come from real close hardware programming. So when Masoud said we're going to do a presentation here at Cloud Bear, I said we better tell you who we are so you understand the background of what Masoud is going to talk about on the technical side. So I'm a field application engineer. I work a little with sales, but I promise not to do any sales, but still I'm going to do a little short update on Wind River as a company.
This is the list we are going through today. So he's going to cover first.
Right, so very short about Wind River. So we are a company that was founded in the 80s by a couple of guys who thought it was very fun to write real close assembler software on top of processors. So that's the background we're coming from. We started with tools, we started to do some operating system, and about 1,200 employees worldwide. We are the market leader in the embedded side, so the chance that you have to use some of our stuff is pretty high. If you ever made a phone call, if you ever driven a car, if you ever taken a flight with an airplane, you probably got in touch with our software somewhere in there. So that's the thing we are coming from. And how does it work?
It's not working for you?
No, I know. So little just little short about the customers. We are active in a couple of verticals, we call them. We very much involved with aerospace and defense sectors, automotive sector, network infrastructure, which is basically what we're going to talk about today. But I want to also show that we are very much working with customer industrial area and mobile consumer area. So this is the foundations of the company where we are sort of skated when it comes to business. And you can see a lot of customers in there. It's natural. This is a little about the products, where they are, how they work. So if you take, for instance, in a virtualization situation, we have a product. You can read about it later on the web, whatever. But it's a product which is based on Openstack, and Masoud can talk a little more about how we use that in some use cases. But if you take like an airplane, satellite, industrial area, self-autonomous driving is quite big for us and these kind of things. This is future technology, but it's some of the most interesting stuff we're working with. And we have products on the Linux side, we have products on the real-time operating side, but mostly now today it's about the cloud. So this is just to show that we exist. We're actually the biggest company in the embedded area. We're even bigger than Microsoft. That has a quite substantial share in the embedded things. Especially if you work on the industrial side, you see a lot of Microsoft deployments out there using Microsoft, all kinds of products, but we're actually more deployed than them. And this is a scale we're working on. So we should mention also that we are a subsidiary. We are owned by Intel. So we are sort of in the parachute of Intel, but we are quite independent, and we work with every kind of architectures and type of hardware, not only Intel. All right, so that's a little about background of the company. And I'm going to leave it over to Masoud.
Yeah, thank you. Today, actually, we are going to talk about 5G. This is the very big area that everyone is talking about. They're talking about which use case is going to be the killer use case in the future, what we should focus on, what we should concentrate on, and what we should think about. So if we take a little bit think about today, we have a 4G. 4G is actually solving a lot of our problems so far. We get a very good performance, very good throughput, up to 100 megabits per second for our mobile edge or mobile access we are using everywhere. But what the 5G going to promise us is the very higher speed. We are talking about gigabit per second. We are talking about very, very high capacity. And we are also talking about the low latency. Because this is the key, that the low latency is the key in the 5G. That most of the companies today is focusing on to solve this problem. This is a very big problem to solve to get in this 5G working. As you can see, the 5G is what we see the use cases usually is about the drones, about the VR and AR, about the connecting the cars. That when you pressing your brake, you don't want to take actually the long time until the car is stopped. You want to have communication between the cars. You know if something is happening maybe 500 meters from you or some kilometer from you. You want to get that information very fast in your car, and your car actually give you that information that you know what to do. So in those use cases, or it is the city that you're talking about, the smart city, and also talking about the VR, that you don't want to actually using the VR and you playing the game, you actually fight, you're going to fire someone, but you don't want to take it a long time. You want to see that this is actually happening in the real time, and you don't actually wait for some millisecond to happen. So this is the real stuff that is going on, and it's going to be very hot this year, 2018, and until 2020. This actually development and real lab setup have been started in last year, 2017. But we have seen in 2018, it's going to actually be planned for new radio. We call it 5G new radio standard. That's going to give you about 20 gigabit per second with the latency about 1 millisecond. So that is what we're talking about. This is from the 10 to 100 millisecond to 1 millisecond or less, or going to the microsecond in some of the use cases. So in 2020, we have seen that this is the actually true 5G, and all the devices we are going to see that going to be in the market, and all the company going to provide to you and to us to use in our lifetime. Then if we take a look at the 5G, then we know that all the application or all the stuff we are doing is not going to require the same matter of requirement. In this case, we come to this slicing, 5G network slicing, that some of the application needs the high bandwidth, or maybe some other actually require the very low latency, or is the combination of those, or some of those is very, very, very high bandwidth. So is this slicing going to be the way we are going to plan our network, plan our application, plan our infrastructure, that depending on the application we are going to use, we slice the hardware, the application, the infrastructure to get those requirements fulfilled for us, for everyone that's going to use different application. So in order to take a look at the challenges we have seen, and everyone actually is working in virtualization, is that you know that we are going to do the virtualization. Kim have talked about this. We have talked about this several years now, that everything going to the virtualization. But when we're talking about the 5G, we know that we are going to get problem with the latency. This is the biggest issue today that everyone try to solve. And we have seen those latency is in the different area. As soon as you using the software, right, Linux or any software you are using, you get some latency in your kernel. For depending on your policy, your scheduling, your processes, your application. If you are using the Open vSwitch, then you get some other area to think about of latency. You get the interrupt latency for all the packet that comes in to the OVS. You get the kernel network for stack latency, and also if you have a multiple bridge configured in your networking, you get the latency for each of those to actually schedule the packet in the right core, the right side of the OVS or Open vSwitch, and how we can handle it. If you take a look at the further on in the KVM, that is then we have also some of the virtualization overhead there. When you entering the VM, leaving the VM, start and leave the VM. So you get some latency in the KVM that should be think about and solve for 5G, to be ready for 5G. And of course, we have in the kernel itself, we have a vCPU permission, and you're going to actually interrupt other CPU to get your done, and set in different priority for your process to interrupt other process and do whatever you want. So there's going to be a lot of context switch between the processes, and that create more latency for your application. all of those is the software. When it goes to the virtual machine itself, then you're going to get all of those again in your virtual machines, because you have a kernel, you have all this stuff that you're running your host in your virtual machine too. So it's going to be all CPU scheduling, all the kernel context switch and that stuff in your virtual machines. So this is the area that everyone is actually focusing on to solve this problem, because this is the key challenge to be solved for 5G. 5G is talking about the latency and latency. So in order to do that, if you take a look at the software we are going to, or everyone going to use, in focusing on the Openstack, the first question is Openstack ready for this stuff? Can we use Openstack for 5G? So we say that the answer is yes. If you have focus and actually go through the different area and do the stuff you want to do. You go to the KVM, do your tuning with the parameter you need to do for KVM to make it real time. You actually accelerated your virtual switch that using, for example, DPDK or accelerated software to somehow can get a better latency, better performance in your application. When it comes to the OpenStack itself, we need to focus on management, how we can manage those applications, how we can manage the VMs, and we can do the monitoring as Kim said, we want to actually do the configuration and have it as a configurable, that you can monitor and configure at the line real time if you want to change anything in the VM. And also have an eye on what's going on and detect the failure very fast and can actually do the recovery if you need it in your system. And of course, it comes to the storage. We need to work with the storage that we also make it available and monitoring system in place that you can have a high availability in your storage solution. So all of those require the hard networking, and that networking is actually the key point of this development. Then of course, the way you are going to implement your software, you need to think about that is independent of which application you're going to run. You want to have a standard API in the top that all the application you are running, you can run in top of your infrastructure. So if you take a look at the problem in the BIOS and OS configuration, maybe this is a little bit details, but I just want to make sure that we see the problem that everyone going to face and how we can easily actually avoid this problem. So if you take a look at the BIOS, this is just disabling the power feature. Some of those give you the better latency. If you go to the sharing and the resources for both the cores and also the memory, you can also do disabling some of the sharing in your environment to make it lower latency, getting the better jitter, and have a dedicated resources for your application. It is also to avoid the latency, you can actually avoid all of those legacy features that most of us we are not going to use in the virtualization environment. And also leverage the affinity. That means that you put your application in the right NUMA zone. I don't know if you are familiar with the different NUMA zone and different socket. If you have a multi-socket solution in your system, put those in the right socket and try to actually control this interrupt for your CPU and for your cores. That you want allocate some of the cores to care of your interrupts, and allocate other ones to do the forwarding for your application. And of course, you can use the device PCI pass-through or the sharing the memory between the VMs. And we have some configuration for the clock that you can actually disable it, the watchdog, that you don't want to watchdog come in and check and interrupt your processor often. This is the area that is very easy to dig in and easy to reconfigure to get the best latency and the JIT. The next is, when we're talking about latency, the next is that using actually moving the data or processing far away from the core, closer to the edge, to your application, closer to your actually device. Doing that, you're going to actually have the processor, you have the data ready, and the fetching those data is going to be much faster if it's closer to your device. Before this MEC, that MEC stands for mobile edge computing, or you call it actually multi-access edge computing too. But that means that you moving the data from the core closer to your devices, that put it in as close as your base station. Doing that, when your device is accessing the server want to have some data, those data are going to be available here. You don't need to go all the way down to your core network to fetch those information. So it's going to be available here and going to be cached, or when you come in there, you're searching for the right data. The data is existing here, you provide it to you. It's not exist, you're going to fetch it, copy it here, cache it here for the next time. So this is all the MEC or mobile edge computing is moving data from the core closer to your devices. That is actually make it, of course, less latency and higher performance for your application access. Then the next is that if you want to provide the solution for this kind of edge application, you want to have a scalable system. You want to have only just one server because this is the edge, or you want to have two servers and scale it up depending on your application. So from one server up to 1,000 or 100 of servers if you want to have a scalable solution for your application. What we have done together with Intel, we have actually started build an Intel 5G Innovation Center in the Shista. There we are going to try to set up the end-to-end solution for 5G together with a lot of different operators and also some of the TAMs. So we try to build this and try to test different applications, make sure that the system is there and we have a right environment set up and find the right parameter, right configuration for 5G to be used in the future. This is actually, as I say, this is the end-to-end solution. We're going to involve a lot of different areas about the data, databases, the compute nodes, controllers, the manual orchestrator, and also the base station that required the 5G radio setup in this case. One of those use cases we actually tested in this lab or this setup using the Openstack solution is the virtual CPE solution. That in that case, you have a different VNFs or application up and running, doing the service training, and try to access and run this application using the actually OpenStack and make sure that you get the right performance, you have a security in place, and also you have a high availability that if some service going down, you have always the service up in another compute node or our server that you never lose your service in this case. So that's the way it is working, and we have actually trying to bring up in the beginning that we're running a VPN session to the edge router. All of those actually application are the virtual machines that we're setting up, creating the different service training. We do the VPN to the edge router. From there, we have a firewall in place, checking everything. And from firewall, we have a services, both media services that is streaming, video services. We have a DNS server, we have a web server with the load balancer, and we have one Windows running for managing the DNFs in this case. The next case that we are actually working on today is trying to bring up what we call is VR or AR that required very low latency, required the mobility that you can actually move from one side to other side, from one place to another place. And also in this case, you want to have a very good resolution in place. So that's the actually next step we are working on. That is actually going to be the real 5G network is required to do this. What is going to be happen and difference is that if you don't use any this edge functionality we talk about, that's when you have this VR glasses on, all the data are going to be fetched from the cloud, from the core, and those going to be streamed directly to you. When you move, you can see that this latency that is required, that we have in this way up to your glasses, is that when you're moving, actually you don't see that actually going to see the black area, because it's the latency in the network actually doesn't allow you to see everything at the real time, that you can actually see what's happening in the real time. But what we're going to actually exercise here, that if we move this one and have this edge compute part that I'm talking about, moving this stuff to the edge, then we should actually see the low bandwidth, low latency. Then you can actually, when you're moving, then you see that the real time, that you see what's happening to 360 degree. You don't actually see or experience any black area in your case. This is actually what most of the service providers are interested in, to see that it is working with this mobile edge computing we talk about, and also the 5G, that they put a real antenna with the 5G network, 5G antenna there, and you connect your devices, your glasses to that antenna, and actually trying to see what's happening maybe far away from you in Los Angeles or whatever it is. So you have a camera there, and in the live you're actually seeing what's happening there, and you see those that is downloaded to the local, and you're seeing directly from this edge processing, that you don't need to go all the way there, and is always caching in matter of time. I think this is it. I don't know if you have any question. There are some backup slides that.
I just mentioned the fact, this is quite interesting. So when talking latency, people think that the speed of light is pretty high, it's pretty fast, right? But if you put the speed of light into context, when you put your servers and try to make them located somewhere in the world, this is actually a figure to get. So if you're, for instance, if you have a server in the old town in downtown Stockholm, and you're trying to access something in Södermalm, you add like 10 microseconds. But if you further move, so if you go to Prague, you will actually have a physical limitation of the speed of light for 10 milliseconds latency round trip, which also means that if you want to do something that requires 1 millisecond or later, you have to have like a edge computing facility quite near you to be able to facilitate those latencies. So we also have like the laws of physics playing in there, which you have to consider when you create these kind of use cases. So this is quite interesting.
Yeah, you can see the application actually, what they are required for different latency in this case. So it's depending on which application you are using, it's just different requirement for latency.
I think if you step, you have that also on the next slide, I think.
Yeah.
Next one. Okay, yeah. So this is the kind of latency requirements we see of different type of use cases. So if you have like a autonomous driving or something like that, you can live maybe with 10 milliseconds unless you have to make some really life critical systems things. But if you have like a a teleoperation where you have to do some search or something around it, you can't live with more than like 7 milliseconds latency for that type of application, because you will have like it's a funny video on the YouTube you can watch where they play football, where they have built in HRV sets with some kind of latency. You see people missing the ball all the time. And this is actually what you get when you have this kind of situation where you have some kind of of use case.
Yeah. So it's when we're talking about 5G is latency. The biggest challenge everyone are working on, focusing on is latency.
Bring down the latency.
Yeah. Yeah, with that, I think I am done.
Yes.